Hey guys, this is section 3.2. Now we're identifying when a function is what we can call a linear function. It means that we have to identify its characteristics to determine whether it's a linear one. It means that if you graph it, for example, you get a straight line. That's part of the characteristics, as you notice in previous examples, right? When you see a graph of a straight line, that's a linear function. If you see a curve, that is a non-linear function, okay? But now we're going to identify the same characteristics here in terms of what you see on a table, okay? So we have the x and the y values. It means the inputs and the corresponding outputs. The first thing that you should do is making sure that the x values are kind of consistent, right? As you can see here, you are increasing the x values by 3, and remember the y values, the outputs are the ones that determine the type of function you have. Okay, so as you notice, as the x's go 3 by 3 by 3, then you can notice that this goes or it is decreasing by 6 every time. That means that this consistency, this constant decrease in this case by the same number, is telling you that we're talking about a linear function. Okay, so this first table is representing a linear function. Now let's take a look at the second and see what we get. Okay, let's take a look at the inputs. 1, 3, 5, 7. It's consistent. Plus 2, plus 2, plus 2. Okay, this is the first thing we need to make sure, but it doesn't tell you anything yet. And now let's take a look at the y values. Here we have from 2 to 9 plus 7, from 9 to 20 plus 11, from 20 to 35 plus 15. All right. So as you can see, these increments are different every time. And if you compare it to the first exercise, now it's not the same. It's changing. So when that happens, it has a specific name, but at this point of time, we're just interested in identifying the linear one. So if this is not linear because it doesn't have a constant change, so I will just say that this is nonlinear. All right, and that's all we have to say. Okay.